Welcome, everybody, to another episode of the Future of Biz Tech. I'm your host, JC Granger, and I have another fantastic guest with us on the show. And if you end up loving this episode at the end, please show that love and appreciation. Go and follow the podcast wherever you're listening right now. Give it a 5-star review. Put some comments in there. It really helps the algorithms, of course, because that is how other techies like you and I find cool podcasts like this. And today, I have the absolute pleasure of interviewing the federal CTO of Intel, Steve Orrin. Steve, thank you so much for coming on the show here. Tell the audience a little bit about yourself and what it is that you do specifically at Intel.
Sure, and thank you for having me today, JC. It's a pleasure to be here. As federal CTO for Intel Corporation, it's sort of my job to understand what the federal government needs from a solution, technology, architecture, and roadmap perspective, what their use cases are, and help them to adopt the current technologies coming from Intel and from our ecosystem, as well as what's coming down the road, what's going to be in 2 to 5 years that they should start planning for today. It's also part of my role to help solve some of those big problems. So when they're looking at whether it be security at the edge or being able to do enterprise transformation and digital modernization, how can Intel and its ecosystem help them achieve their big goals? And then the final piece, which I think is really the fun part, is translating all of those use cases and those problem sets back into Intel so that our engineers and our architects can build for those future use models and build technologies that keep our customers happy.
Well, that's really cool. And let's talk about real quick here. This is the first time I've heard this particular job title, federal CTO, right? So you talk about you work with the government. So how is that structure of Intel created where you're over here in a C-suite specifically for government? I mean, and do you have anything else under your umbrella other than that?
So that's a very good question, JC. The way to think about a federal CTO is while I am off in a specific division, it's the federal division for Intel, where we focus on engagement with the federal customer and its ecosystem, so the integrators and the federal divisions of other software and hardware companies. My charter is much broader. It's really about understanding all that Intel does and providing value back to the mothership. And so as the CTO, I'm the lead technologist for all government engagements, but it also means I'm the voice of the customer back into the organization. So just like you would have a cloud CTO, or you would have a memory CTO, or a client CTO, the federal CTO's role is really to represent that entire market back into the business units, and to help the business units to reach into that customer base so that their technologies and their new innovations and incubation projects are on the radar of the various different government procurements, government programs, and of course the ecosystem that's adopting technology for the federal government.
Okay, and then so, how does the government via Intel work with like maybe small businesses? Is there a path there? How does that work? How do the businesses fall under your umbrella when it comes to that via the government, or is it just straight with the government and then they handle the rest?
So it's interesting, if you think about how the government procures things or how the government buys or deploys technology, very rarely does the government go directly to a software developer and say, give me your software. It happens, but oftentimes there's an integrator or a solution provider that pulls together the software packages and the systems and builds it on behalf of the government. And it could be large primes like Lockheed or Northrop or Raytheon that are building a lot of the weapon systems or building planes or boats, or you get the large contractors that are building IT systems, the Leidoses, the Booz Allens, the Khakis that are building sort of the ERP systems for the VA or for the IRS. And so the ecosystem that supports the federal government is different and diverse. At the same time, when you pick on small business, it's really interesting. The government has a special set of programs. They call it SBIRs, so small business investments. And what it does is for many of the big contracts, they actually have language in the contract that an SBIR, a small business or a minority-owned small business, needs to be as part of that program, or in some cases has to lead. And so there's a whole market of small companies that service the federal government that basically helps that small business get into federal contracts, get those dollars, employ people at the small business side, and then can tap into the larger primes and tap into the larger ecosystems to help fulfill or to provide the technology. So you may find companies like Microsoft or Amazon or Intel or others that are partnering with a lot of small companies on these specific opportunities and contracts that have that carve out for small business or for minority or veteran-owned small businesses. At the same time, one of the things that Intel provides, because the reality is most people don't buy things direct from Intel. You go to the OEMs, you go to Dell, HP, Lenovo, what have you, to buy a laptop or a server, or you're getting services for an Amazon or an Azure or a Google Cloud that runs on Intel. You don't necessarily buy direct from Intel. And so our relationship with the federal government really comes down to being more of a neutral party, if you will. We're not vested in which one of the OEMs or which cloud provider you purchase or you go with. So we help them provide the right choices around the architectural approach. And we bring our large ecosystem, both the big players as well as small, nimble, rabbit-style companies that are doing innovative things with hardware technologies. And we can expose that ecosystem of small businesses and startups to large customers like the federal government or financial services or healthcare organizations, because we really want to show the best of what you can do, not necessarily just what the current server box can do today. We want to show what the advanced capabilities are. So we spend a lot of time, and we have a very rich ecosystem of small and medium-sized companies, startups, as well as well-established ones that do interesting integrations, build unique and pretty awesome software, especially if you think about today in the areas of like AI and 5G and in cloud services and microservices. There are a lot of amazing little companies, and we then highlight those and bring them along as part of our ecosystem.
Well, I mean, like it says, Intel inside of everything, right? So, well, and let's talk about that here too. So, obviously in the news here lately, we keep hearing about chip shortages, right? So, help me understand, what is contributing right now to the chip shortage, and what industries other than tech, for example, is that affecting the most right now?
So you bring up a good question, and let's just face it, the semiconductor supply chain is very complex. But if we get to the heart of it, and it's really not a particular, like high-end chips that are really the key shortage right now, whether it be Intel or other modern state-of-the-art technologies, there are actually lots of supply available today to meet the demand. The challenge oftentimes, and you hear about it all the time with like the automotive industry or appliances industries, it's not the state-of-the-art chips that are actually the ones that are constricted right now in the supply. These are the really cheap low-end chips, the legacy chips, what they call the legacy process nodes, that do simple things like power regulation, voltage regulation, do network switching. So these microprocessors that are still absolutely crucial. If you think about every laptop you plug a power cord into, there's a little chip behind that regulates the voltage and controls the power distribution across the board. Those are the chips, for example, that are in short supply and that are almost exclusively made overseas. And without that chip, you can't build the laptop. You can have all the state-of-the-art processors, but if you don't have the cheaper chips, if you will, or the lower end chips, that's the ones that we're seeing affect a lot of the supply chain. The automotive industry is a very good example. They chose as an industry to stay on certain legacy chips because it served their needs. They didn't need the higher end chips to control, the voltage regulation across the alternators. And so they stayed with a legacy chip that was easily available and very cost effective. And those were the chips that were hit most hard by the supply shortage. Now, it's across the board. I'm picking on the power regulators. There are multiple chips in this class of low-end cheap chips that are currently supply constrained. It's getting better in two levels. Number one, we're starting to see visibility into those supply chains. They're starting to tick up. It's still a long lead time. But I think what you've seen in the news and the media and coming out of the federal government around things like the CHIPS Act and other executive orders is focusing how do we deal with the supply chain issue at a global scale. We need to pick up production locally. Mm-hmm. And that means investing locally, investing in small and medium and large companies. And it really has to go across the board. Large companies like Intel and others, as well as small manufacturers that are building the components, those little cheap chips, or the substrates, which is the platform that you put the chip onto. Mm-hmm. And making sure that those are built domestically. Same thing we're seeing happen in Europe. Europe is also looking at how do they help with the global supply chain issues to bring manufacturing back to the Western Hemisphere and also to be able to have diversity so that you have availability in the US, in Europe, and in Asia, so that wherever you need the chips, you can get them. By having sort of critical path or single points of failure, I think COVID pandemic really illustrated that our global supply chain can be very fragile. And so we're seeing a renewed investment here.
Yeah, it was a hell of a stress test, right? I mean, I think we found a choke point.
Yep,
right?
Indeed.
So what's Intel doing about that? Are you guys building manufacturing plants in the U.S. or in Europe so that you can solve your own problem and with that shortage?
So our new CEO who came in February, Pat Gelsinger, has really taken this under his banner, has made it a key strategy for Intel. He's called it IDM 2.0. And there's sort of multiple parts to this strategy. Part of it is investing locally and being able to have increased chip production in the US and in Europe. And to that end, we've already struck ground on new fabs in Arizona, as well as there's work going on in Europe as well and other places to be able to increase our production. But that's only part of the conversation. The other part around IDM 2.0, which is a big shift for Intel, is it's not just about building, like I said, it's not building only Intel chips. We actually have really good supply. It's about how do we help the broader ecosystem? How does NVIDIA and Microsoft and Apple and others get access to be able to build their chips on our foundries and in our fabs? And that's the big shift. And so it's not just about building more capacity for us. It's building that capacity to be able to support the ecosystem and the OEMs and the other and nowadays even companies like Facebook and Microsoft and Amazon have for certain parts of their workloads their own custom chips, their own ASIC accelerators, and giving them the ability to build those domestically is going to help them to meet the future short supply chain issues of tomorrow. So the good news is there's an answer and it's being worked on. But the thing to remember with anything in the semiconductor industry, this is not it's not like software you can bang out a new piece of code in 6 months.
Yeah. Well, let me ask you this. I mean, I've always wondered this about Intel specifically. You guys are so good at playing nice with others, right? Like you're like that kid in high school who could hang with any of the cliques, right? And I have to ask you, how have you guys managed to not only work with so many other big tech companies, but how have you guys avoided all of the political stuff and the scandals and everything? Like, I mean, just if I feel like every day we turn on the TV and there's another tech company that's getting just chewed out by the media or by other tech companies, and it's like, and here's Intel over here, like Switzerland, just super neutral, likes everybody, no one has a problem with them. Even the supply chain shortage of chips, nobody was blaming Intel. It's amazing. If there was one time that you guys were not going to get away with this, this would have been it. And nobody is going, how dare Intel not have figured this out before? Like, how have you guys stayed so clean? And then what is that, how do you guys work so well with others, I guess is my point.
So I think it comes to three things. I'll give you three answers. One, it's a bottoms up and a tops down. Having good leadership that sort of drives that we need to be the enabler of technology, whether that technology is in our OEM channel, our cloud channel, even with our competitors or co-opetition, as they like to say, it still needs to run on Intel. They may be using their own accelerator, they're not using our GPU, they're using their GPU, but you still need an operating environment, still need a CPU to drive the server, to drive the client. And so understanding our role there about how we enable the entire industry. And it comes down to like I mentioned, the bottoms up. We have really good engineers. I think one of the things, I've been with Intel 16 years, and there are people at Intel that have been here for, there's someone I know who's retiring after 32 years at Intel. He spent his entire career. We have lifers here, and it's not because they have nowhere else to go. I mean, the industry, as you know, the talent is being pulled left and right. Is that we are enabled by engineers for engineers, so the engineers are driving technology. And so you don't get a lot of those politics when you're trying to solve big problems. And to give you a really good example, when I came to Intel, I came from the startup world. I had done multiple successful startups in the security space. One of them got acquired by Intel. And when I thought about, well, what should I do now that I've been acquired? I'm going to go find my next startup. My most successful company, we had 500 of the Fortune 1000 using our product, which is a huge success for a startup. I mean, that's half Fortune 1000. They were using our product. It was great. The first technology I worked on at Intel went to 40 million PCs. And so the impact you can have is that much bigger. And so when you're an architect or an engineer or a program manager working on a product that's going to change the way people compute, that sense of pride and the sense of accomplishment you really can't find in other places. So we understand our role and take it very seriously.
You guys just seem bulletproof, man. I mean, you're not even coming up when they're talking about hacks, right? And like information being hacked, and so no one's saying, oh yeah, well we found a way to exploit the Intel chip, and that's how like you just are bulletproof in this, and I find that fascinating, to be completely honest.
Well, let's face it, there have been some published vulnerabilities in some of the firmware and some of the hardware. It happens. No one is immune from that. I think what makes Intel a little bit different is how we handle it. So we've been very advanced in our proactive nature of working with external researchers, so that when a bug is found or when a vulnerability in our systems are found, we're proactive. We're already working with those researchers so that we're taking in their input and working on those fixes and working with them so that the industry can get updated and fixed. We're not hiding things like some other companies or trying to make a big deal about it. Our goal is that if something is found, we want to make sure that all of the OEMs can fix their products in time so that there isn't a vulnerability for the end customer. And so working together with the ecosystem and the researchers is something that was built into our DNA from a very early stage.
That's very cool. And I'm a Bay Area boy myself. My dad worked for Sun Microsystems for like 20 years. I was running cord between walls because I was small. And, take your kid to work stuff. I still remember, like, I can still hear the hum of the server rooms, right? So like this stuff fascinates me. I love this, and I think you guys are great. I have a question though. Let's talk about the future, right? This is the Future of BizTech podcast. Let's have a future question. So where do you see, and we touched a little bit on this earlier regarding, building supply chains locally, right? Like nationally here or in Europe, so that we don't have this issue of that again. But where do you see your industry going, or even, in the next 5-10 years, whether it be through technology or legislation? You work with the federal government, obviously, so that there's a lot that happens with that. Where do you see Intel in that next 5 to 10 years, and the industry as a whole?
So I think one of the big things that's happening right now, and it's subtle, that everyone hears about the buzzwords, AI, 5G, those big technologies, but there's a reason why those are happening. And it's really about the proliferation of the edge. What is edge computing? And we used to call it just IoT, but IoT was too narrow because it's, you think about, it's my smart light or it's a camera. Edge computing is really about the diversity of devices and things out there in the world that are both connected and creating or sensing data, and then processing and transport. When you think about a car, the stoplight, the smart city infrastructure, the cloud, all working together, where you've got distributed processing. So everything is doing some process, everything is sensing and collecting. Your phone is an amazing sensor platform. Your car is a driving data center. A plane is a flying data center. So you have all this data be collected that's got to be processed, got to be transported, and results and actions have to be taken. That's why 5G and AI are really at the forefront of what's driving this next 5 years of evolution. It's because we need AI to make sense of all of this data that's coming at us at real time. And we need 5G to be able to have that data move between systems and to the cloud and back again, and be able to do it
fast
efficiently.
enough speed, right? Like
Exactly.
real time, basically.
Real time and high definition.
Mm-hmm.
And so that's why 5G and AI are so important, is because they are these, if you think, the fuel that's going to drive this next generation of compute. And when you see the trends, people talk about the cloud as this thing in the sky and everything's going to go to the cloud. Under the covers, what people have recognized now is that it's not just in the cloud up there at Amazon in Seattle or in their different regions. The cloud is being extended all the way out to the edge. And so whether it be things like Amazon Outpost or Azure Stack as examples of this, of them taking their cloud capability and dropping it in racks that then could be deployed at an enterprise or deployed in the field. So you think about energy distribution. Inside there's a rack of servers at every one of those energy stations that's processing, sensing data about the flow of energy. It's a mini data center. It's an extension of the cloud. And that data, of course, has to be analyzed in real time so you can respond. So those transformations are the key drivers of innovation. So we look at what are the next 5 years. We're going to see continued acceleration for what AI can do and the places it will touch us. In some respects, that's already happened. We just don't realize it. Everything that you do on your phone, on the web, in your business operations are affected by machine learning and AI. When you make decisions about where to purchase your products or how to build your systems or how to get better efficiencies into your development processes, all that is informed by machine learning AI because the products you use are leveraging them. That's going to continue to accelerate. The other thing that we're seeing is as Moore's law continues to climb, as we see more and more computing being able to be done at a lower cost and lower power, we start to hit a point where we're going to see transformation in the kind of activities we can do. So we're seeing people talking about quantum computers. They're probably still a good 10 years away before we have functional, commercial quantum capabilities. But before we get there, we're going to have exascale capabilities in the next year, where we have supercomputers that now can perform functions in days or if not hours that used to take weeks, if not months, if not years.
And
And so that
that's kind of always how the technology goes, right? I mean, we talk about how there used to be, it took a whole room to hold one computer, and now we have 100 times the capacity in our phone than that, you know?
Exactly, exactly. And so when you start thinking about that kind of scale, it applies to everything. If you're designing the next generation car, and you have to do sort of the temperature models, the flow models, the risks on how it will handle in a crash, you can do those designs much faster now. And so what maybe took you weeks can take you minutes, and you can make design changes in real time. That means that whole innovation cycle speeds up. And so now cars can get designed and built and customized more quickly. That changes the business model. So now the audio industry starts thinking about, well, can we do custom car domain or on-demand delivery like the PC industry does? And so now you have transformation in business that are enabled by technology. So technology is not going to change your business directly. It's an enabler. But now that you have that at your disposal, the business can now operate like technology does. And so you start getting transformation of industries, whether it be classic brick and mortar, industrial, oil and gas, automotive, or B2B software and ERP systems changing now. In the past, you had to go buy a big software to do your ERP.
Mm-hmm.
And then maybe you brought something inside, outside, and now you can do some of it in the cloud. But with microservices and distributed multi-cloud strategies, you can basically distribute your ERP across all the best service providers out there and get exactly what you need. And then what that means is, it reduces the cost and overhead of the maintenance of the actual system, but it also means you can innovate your business without having to change the way you do ERP. If you want to be able to go try some new business model or new revenue stream or new licensing approach, you can get a microservice that will enable that into your systems without having to re-engineer the whole thing. That means you can have the ability to be agile in your business structure. Again, changing the way businesses do business.
Yeah, and that gives us such an exponential curve up too. I mean, and I think that's the thing that people maybe don't even understand or appreciate sometimes, is that once some of these things you're talking about, like with the AI mixed in with 5G, just speed plus intelligence, when you combine those, people forget that that's a hockey stick move right there, right? That's going straight up, and it could be unrecognizable, in 5-10 years, right, from where we're at today, for example. And then we look back, it becomes kind of like that Amazon idea, like next day or 2 days shipping. We're so used to that now.
No.
And one day it'll be like 1 hour shipping. It's like, how did you get that? And we get really entitled about it too. So let's talk about what's coming up for Intel. My audience loves the inside scoop, and you guys are such a big and well-known company. What and it can be within your division or just in general. What is something that people maybe don't know about just yet that Intel is going to be releasing or showcasing or advancing here pretty soon? What do you give us something? Give us a little bit.
I give you a little bit. So recently we showed off at the Intel Innovation Conference, which just happened a couple of weeks ago, some amazing new technologies that are coming to market. One is our latest generation of client platform. It is unbelievable the amount of power and computing that we've been able to pack into this system, into what's called the Alder Lake platform. The other key thing, the thing that's exciting for me, is all the security features that are now built in out of the box inside the Intel platforms. And it goes across all areas of security, from being able to make sure the system is intact, so when you boot the system, it's all good and nothing has gotten inserted on it, to protecting your data in light of the threats that we deal with. If you think about it right now, we always hear about ransomware and data breaches and all these different problems that are happening on a constant barrage. Part of the problem is the data itself is not being protected wherever it lives, on the PC, in the cloud, in the data center. And by having technologies built into the clients and the servers and the network stack, where Intel lives at all of those places, that can protect the data end to end. And I think that's the big game changer, is when you can protect your data end to end. That's the game changer. And that's what Intel's building into our technology, into our CPUs, available now. And then the last thing that I think is really interesting is we've also taken a look at those vulnerabilities. So software vulnerabilities have been a bane for 30 plus years.
Sure.
Every time you turn around, there's another operating system attack, an application attack. Yeah. So what Intel has done is start looking at ways where you can use the hardware to either detect or to close those vulnerabilities. And so two technologies we announced just now. One is around closing a class of vulnerabilities in software called return-oriented programming, and being able to basically use the hardware to block it. And so if your application or operating system is taking advantage of that hardware feature, those attacks no longer work. And so it's like eliminating an entire class of vulnerability just by running on the latest hardware. And for me, that's very exciting. It means we can affect the day-to-day lives of everybody.
Yeah, that's huge. I mean, that's absolutely huge. You hear about ransomware and stuff, and happening even just to individual people. They sit there, they lock up their computer, and you got to give them Bitcoin so they can unload it. So I mean, from a consumer standpoint, I think that's fantastic, and I can't even imagine how big it's going to be on the federal side for the government side, which is where you mostly operate. So I think that's really cool. I'm glad that, and thank you for telling us that. I think it's really cool that's coming out. We'll have to keep an eye on that. I'm going to switch gears here for a second, though. I want to just ask a personal question, right?
Sure.
It sounds like the cliche personal question. What did you want to do when you grew up, when you were a kid, right? Like what was your dream, and then how did you get to where you're at now? And are those the same thing? Like, did you say I want to, be high up at a big software company or hardware company, tech? So like, what did you want to do when you were a kid, and then how did that transition to now?
It's a very good question, and it's a fascinating story. So when I was younger, I had two loves: computers and really hacking, and the other was biology. And so as I was, so sciences and basically for me, it's about solving problems, whether it be figuring out how things work and hacking things, or understanding biological processes. It's really about how do you solve problems, how do you answer those hard questions. That's always fascinated me. About the time I needed to sort of figure out what did I want to be when I grew up and go to college and actually have a career, computer science wasn't really an exciting option at the time in the late 80s. And so I went the bio route and I actually did a research biology degree. I did graduate research in biochemistry, and I was going to become an MD PhD and work in a lab for the rest of my life. That was my career. I was going to publish papers and do really cool science. And right before I was going to start med school, I had sort of a period of time where my grant with the government, a government grant had run out for some research I was doing. And so I had some time before I was going to start med school, and a friend of a friend had some money, wanted to do a startup. Now remember, this is early 1995, pre-Netscape IPO, early days of the internet. And so he said, hey, you want to help me? You know this hacking stuff. Can you help me with this idea? And so I just said, what, this would be a good idea. I have saved some money for med school. Well, 3 months into doing it, I fell in love. And this was, again, the exciting early days of the internet. Wow. Did my first startup in 95, grew that startup, and then in 98, decided to go do my own and started my own company and did that one, and then just did serial entrepreneur through the 90s and into the mid 2000s, and loved every minute, and really got the opportunity to work with some of the luminaries in the security field. My mentor, Bruce Schneier, and others sort of taught me the keys to understanding cryptography and understanding applied security early enough in my career where I've now been able to pass that along to people I mentor. And then doing the startup thing, that's where I went. I was like, I'm going to be a startup guy. I'm going to start companies in the security space and solve hard problems. And then it got acquired by Intel in 2005. And like I said earlier, I was going to go off and do another startup after 6 months. And they gave me the opportunity to run security pathfinding, which in Intel, what that meant is looking at the 2 to 5 year horizon. What are things we could do with our hardware as it exists today or as it's coming that would be innovative for security? And so for 8.5 years, I ran sort of the advanced research around software usages of security. So things like anti-malware, antivirus technologies, leveraging hardware, web and cloud security, virtualization security. Fascinating stuff that, again, as we built these features, they affected the entire industry. And so I did want to become a doctor at one point, but I went, stage left and became a technologist, and really got to use my hacking skills and my security background, and the things that I did in the 80s have served me well throughout my career.
That's awesome. I always like asking that question because just hearing that journey, and it's always a different path, right? And it's almost never like what someone wanted to do, like when they were a kid, right? And so I think the best part is like, okay, well, how did it get there? How did it work its way to where you're at now? All right, so last question then for you. You're a tech guy. I'm sure you do a lot of research and reading. If you could give one recommendation to the audience of maybe like the best book, right? Whether it be audiobook or regular, and you can pick your theme of it, if it's tech or not. But what's kind of like a must read in your world?
It's interesting. There are two books that I go back to, and one is not a technology book, but it is a book that has really taught me so much about how to run businesses, how to run teams, and how to work within an organization, and that's Good to Great by Jim Collins. One of my early CEOs that I worked with in my startup days had recommended I read the book, and she was friends with him, and so he came in and talked to us, and just had such an impact, both that book and his follow-on. It really was understanding the dynamics of what makes businesses work and what your job there is to do, whether it be surrounding yourself with people smarter than yourself or understanding the core of what your business really is, has advised me throughout all my technology. Because while he talks about it from a business sense, it applies equally to the technology sense. So that's one that I live and die by, and I still go back and look at it. And as far as the technology books, there are so many right now. But the one that I read first and that I still point to as sort of the one that got me started was Applied Cryptography by Bruce Schneier, by my mentor. They sometimes refer to as the big red book because it's about yay thick. But one of the key things, and he's had multiple books that have followed that have all been great, but the key thing is that it's not about the math. A lot of times engineers say, I'm going to build the perfect crypto algorithm, or I'm going to build the perfect compiler. And really what it comes down to, it's about the application of that technology. That's why it's called applied security. So how do you apply the cool technology to a problem? Yeah. And that's the theme that sort of rides throughout the book and throughout his talks. It's not about just the math. It's not just about the code. It's how do you solve a problem? How do you solve a customer's problem or a business problem or your own internal development problems using technology? It's not about the technology as the end. The technology is a means. And I think that's the key thing that you learn from that. And applied cryptography is really about how do you apply cryptography to email, to network protocols. And that's really the lesson learned there.
Yeah, I really like the application part of it because, I'm more of a practical type of person. Right? That's how my brain works. I'm like, okay, well, that's great, but how do I use it?
Yeah, exactly.
Like, how is this going to make my life better, right? So how can, and listen, by the way, Steve, thank you so much for being on the show here, but how can people reach you personally? Normally I would say, how do they find the company website? Well, it's Intel. We get that. We know where to find Intel, okay? But if anyone listening is on that more higher level and they feel like reaching out to you for like a really big enterprise style conversation, how can they contact you?
So the best way to get a hold of me, honestly, is through LinkedIn. And so it's SORRIN on LinkedIn. So linkedin.com/in/Sorin is the best way to get a hold of me. Just reach out with a connection request and I'll accept it. And that's the best way to get the process started. And this way you don't get stuck in a spam filter. So that is the best way to get a hold of me. And again, it also is where I publish, so when I'm doing conversations, when I'm putting out articles, that's where you can see the greatest, the latest of what I'm talking about these days.
That's awesome. And listen, hey, for everybody here listening out there, again, if you liked what you heard today, be sure to subscribe to the podcast, give it a 5-star rating, put in some cool comments in there so other techies like us can find it and enjoy learning about all the cool, amazing B2B softwares and tech like Intel here on the market today. Steve, again, thank you so much for being on the show. And I really look forward to publishing this. And I think I'll have to call my dad and be like, hey, I just talked to Intel today.
Well, thank you, JC. It was a pleasure being here today.
Have a good one.